Hey guys, this will be a video for the third unit check of Unit 3. I'm just going to go over my solutions and walk you through. So if you're looking at the problems, you should be looking at the problems while you're doing this, but I'll explain how I get to my answer. So for the first problem, we're given a graph, and the graph kind of looks like this right here, and it's got a tangent line, right? And so what and it says the graph is the increasing differentiable function f, and also shown is a line tangent to the graph of f at the point 2, 4. G is the inverse of f. Which of the following statements about g prime is true? So f, I know, has a tangent at the point 2, 4, and its slope is 3/2. So if you look at the slope of the tangent line, you can count that the slope is 3/2. Therefore, g is going to have a slope of 2/3, but at the point 4, 2. And so that basically just reduces down to g prime. So g prime of 4, because we're at the value of 4, is going to be equal to the reciprocal that we have stated here. So 2/3. So that's going to have to be C. Okay. Next we have a question. It says let f be the decreasing function defined by f of x equals. It gives us a function. Now we don't even need the function really. All we because the answers provided don't even use the derivative. It just uses the notation for the derivative, I guess you can say. So it says f of 4 is equal to -8. So f has a point at 4, -8, and the slope then, the slope is f prime of 4. So we'll just say f prime of 4. I don't actually need this value though, because the answers don't actually define what the value is. They just say f prime of 4. But if we remember here that that g is going to have a point at -8, 4, and the slope is going to be the reciprocal to this. And how do I write the reciprocal? I'm just going to write it as 1 over f prime of 4. That just means right here, this just means the reciprocal of whatever value that is. And so that's going to be B. For 3, so we're given a table, and we're trying to find the correct expression for g prime of 0. So g prime of 0, we know that g is the inverse of f. Okay, and so if you remember that formula that we used in class, where we took the derivative of the inverse, that's the inverse derivative, that's equal to the derivative of the inverse function at 0. So I have this is just the formula that I have here, 1 over f prime of the inverse at 0. So if I look in the table though, the table doesn't have any information for g, only information for f. But remember that g and f have an inverse relationship, and so I don't want to look for 0 as an input. Instead, I want to look in the outputs of f for 0, because the outputs are what's going to be or what I want for that. So if I look in the table, 0 for f of x occurs when x is equal to -4, and so g of 0 is going to be -4. And now I can use the table. I know that f prime of -4, if I look in the table, is going to be 1. So I get 1 over 1, which is equal to 1. So that's going to be C. The next question gives us the derivative of inverse of x squared. So if you use your shortcut rules, if you look at the top, we're taking the derivative of the inside. That's just the chain rule. Derivative of the inside is 2x over the square root of 1 minus x squared. But here we have x squared being squared. So that's going to be x to the 4th. And we plug in 1/4. It doesn't matter. So I'm going to plug in 1/4 here, and that's going to line up with B. And then for the last question, we have the derivative of the arc cosine of negative 3x. So remember that the shortcut here goes -1, but in this case we're going to have we need the derivative of the inside, which is going to be -3, so that's going to be +3, divided by the square root of 1 minus x squared, but instead of x we're going to use -3x being squared, and so that's going to be option A. That's going to be +3, so A should be the answer there. Okay, and that should be everything for the third progress check.